Motivo Data Analytics Private Limited in Bangalore. Educational background is I did ECE, and then after that I did masters in VLSI, College of Engineering, and then I started my professional career as a VLSI physical designer back in 2003. So we are in 2024. Roughly about 21 years I am in the field of VLSI, and I want to share the latest field in engineering, which is getting lot of attention in terms of business, in terms of academic research, and also the connection of that field of engineering to VLSI or electronics. So this presentation is about going through the fundamentals of artificial intelligence, the very basics, because I want to keep the introductory presentation as basic as possible, so that it generates some amount of awareness and it generates some amount of interest to you guys. And with that, I'll get into the contents. So this would be the flow. We'll go through the introduction and then a brief history about AI history and its evolution, and then what are AI chips, what does AI chip mean, and what are the different types of it, and how is it different from any other chips that you know of, and what are the different use cases in which the AI chips gets utilized, and then who are the companies who are today working in the field of artificial intelligence and the technology that drives it, and the current trends, what are the specific advancements, and what is the future for the AI architecture, how is it going to evolve, and then some basic AI chips related comparative studies, and then in terms of efficiency, speed, and then what must to create a chip or AI, and who are the players working in that field. And then AI glossary, where you get a lot of buzzwords related to AI that you will come across going forward. And then how AI algorithms work, what are the basic classification, and then conclusion. So this is the basic flow of the presentation that we are going to go through. So it's clear, right? Am I going in a very fast pace or is it followable? So artificial intelligence, though we have started hearing this term very frequently now, it's not a very new study. This has been there for more than 70 years. The basic root cause or the basic root of artificial intelligence dates back as 1940, 1950s. So there is a person called Alan Turing. I don't know whether you have heard about this name. He is the person who won the World War II. If you have had a chance to watch this movie called Imitation Games. The Imitation Game is an English movie which is based on Alan Turing and how the innovation of the Turing's machine or the computation machine that they talk about, how it won World War II. So that so he published a paper in 1950 with this opening sentence. I propose to consider the question: can machines think? So this is the sentence with which he started the paper. And then 5 years later, a conference called Dartmouth Summer Research Project Workshop, it was conducted in 1956. That is where they formally proposed a field called artificial intelligence, and then they gathered a lot of people who are interested in it, and then they started the rolling of the research and the formal study around artificial intelligence. So any machine is considered intelligent if it cannot be distinguished from a human being. For example, now you have two systems, right? Two computer systems, and you have a ceiling in front of it, and you are sitting on front of that. And if you pose question to each of those systems, and one is operated by a human and one is not operated by a human, if the type of responses that you have, you are going to get from both these computers are identical, and you cannot differentiate as which one is driven by a human and which one is not, then that test is called as Turing test. And till now, we can say literally no computer system has passed the Turing test. Something that has come very closer to that is the OpenAI's ChatGPT. I don't know how many of you have heard this name. OpenAI is a company which is operating in generative AI, and ChatGPT is one of the front-end applications that it has provided for users to have a conversational transaction with the machines. So that is sometimes people say that that comes very closer to passing the Turing test, but so Turing test is one of the primary criteria with which one can measure the intelligence capability of systems. So artificial intelligence is it's a broad field of study which includes machine learning, which includes deep learning, and so as it says, whenever a machine is made to mimic the cognitive functions, meaning what are the cognitive functions? Seeing, observing, sensing, and then classifying. So these are different cognitive functions normally human possess, right? If we can make a system to do all these things, so a field of study that talks about is artificial intelligence. And machine learning is a field of artificial intelligence, a subcategory of artificial intelligence in which the machine goes through a large amount of data, a vast amount of data, and it is trying to gather information about the data. It tries to find what the data is about, and with that it is able to derive some decisions. So that is the field of machine learning. And deep learning is even more a specific function under the machine learning, where a specific methodology or specific architecture, basically neural networks, are the fundamental hardware architectures that propels both these deep learning and machine learning. So, and generative AI is going to be one subset of the artificial intelligence, which sort of overlaps between deep learning and machine learning. And what are AI chips? When I say AI chip, how is it different from any other chip that I use? For example, a 555 timer that you use in your lab is a chip, right? Power management IC that you use in your lab is a chip, right? Then the most common chips that we are aware of are microprocessors, right? Typically, when you go to the market, you get the terms like AMD, Intel, which are the companies which make microprocessors, right? And then NVIDIA, which make GPUs, general purpose graphics processing units. So, if I have to define AI chips, right? AI chip doesn't have a unique classification. It is not a single chip, right? Any hardware circuitry, which is a chip, which can work on AI type of problems. What is AI type of problems, right? So, those are designed, are architected to handle problems of AI capacity. And wherever there is a need for making human intelligence type of decisions, human intelligence type of applications, those problems and any single chip or a combination of chips which can be deployed to do that function, those are called AI chips. You can use a CPU for AI workloads, you can use a GPU for AI workloads, you can use an application-specific integrated circuit for the AI workloads. And FPGAs are field programmable gate arrays, which can be programmed to any functionality that you want to implement. For example, if you want to realize a fast Fourier transform, or if you want to realize any other signal processing algorithms that you normally go through in your curriculum. If you want to do that, the quickest way to implement it and test its functionality is FPGA. These are prefabricated circuitry which has different computational elements, memory elements and everything. You can program it to realize a particular functionality. That is what field programmable gate arrays is. So these different class of chips together form the umbrella of AI chips. Now, in the machine learning, there are two distinct functions that helps the learning function, right? One is training, the other one is inference. To give you an analogy, if you have a face detection, or if you have an object detection system that was designed to identify what type of object that you show in front of it, right? To make that function, to make that system function to the respective task, you have to first train it. For example, if you want a system, an electronic system, to identify cats from a list of animals that you are going to show in front of it, right? First, you have to train the system by showing cats of different colors, of different size, of different species, right? There are so many cats, right? So that phase is called training phase. And second is inference. Inference is once you have trained the system, then what you do is you now show different animals together and see whether it is able to detect the cat properly or not. For example, cats, domestic cats are one category, then wild cats are another category, a lion is a cat, cheetah is a cat, everything comes to the cat family, right? So once you have trained it with the basic set of cats, and once you show it at different species of the cat family itself, is it able to detect properly or not? So that type of functions is typically categorized as training function and then inference function, right? So, so there are chips which are specifically designed for training purpose, and there are chips which are specifically designed for inference, and there are chips which can do both of these functions together. So these are a type of AI chips which are typically used for the machine learning applications. And when you talk about AI chips, right, this is hardware accelerators. This is one terminology that you would come across when you start exploring about this field, right? Hardware accelerators are again GPUs, FP, matrix multiplication. When you have studied mathematics and matrices, you would have not come across a practical usage of matrix multiplications. Matrix multiplications are the primary driving factor behind all these AI technologies, right? How efficiently can you do it? So CPUs are also used for this, but because CPU is designed for a very generic purpose, the speed at which it can support an AI workload is very minimal. So it's like employing JCB, right, to just pluck a few grasses. Right? If you design a specific device for plucking grasses, that would operate much faster at a much lower cost and much power efficient way than employing a CPU for doing that. And you would also come across something called as TPU. TPU is nothing but tensor processing units. Again, when you go and do a basic study about tensors, and tensors are nothing but a representation of a matrix data in a basic fundamental functional form, right? The matrix components during the multiplication, one way of representing it is tensor. And Google is a company which extensively worked on these tensors and the way they can do tensor multiplications. So basically, to multiply a 2 by 2 matrix, right, you need 8 multiplication functions. So you have a 2 by 2 matrix, matrix A and matrix B, and if you want to get the product of the matrix A and matrix B, you have to do 8 multiplications and then additions to realize it. The more more advancements or reduction in the number of functions needed for doing this multiplication, the more your computational efficiency is. The more your circuit is going to be faster. You can do the same matrix multiplication in seven operations. You can do the same in 5 operations. All that is associated with mathematics. Right? So whenever you are learning mathematics, right, in your engineering curriculum, if you pay close attention to it and find a practical application of it, whole of the industry is working behind it. And neuromorphic chips. Neuromorphic chips again are a type of AI chips, but mostly their practical usage or the commercial usage is now in the nascent stage. They are mostly in the academic research phase only. Neuromorphic chips are basically constructed by mimicking the human brain, how your human brain works as a collective effort of neurons, right? It is Google's brainchild, and those are the tensor processing units are used for making tensor computations, which is an essential component of a neural network. And all the data centers of Google use tensor processing units. Earlier they were using CPUs from companies like Intel, AMD. Now, after identifying that the general purpose CPUs cannot support their workload demand, cannot support their usage for the end user to have a better engagement experience, they decided that, okay, I know what needs to be done, and all I need to have to do is assemble hardware engineers and ask them to implement what I want to implement, right? So they started having their own hardware design team, which were given the task of designing a TPUs, and then most of the data center that Google has runs with a combination of NVIDIA GPUs and their TPUs. FPGAs, again, companies like Xilinx, companies like Altera, these are the companies which are very well known in the field of FPGAs, though there are a lot of other small companies. These are the companies which support state-of-the-art chips for heavy computing. Now, Xilinx is acquired by AMD, Altera was acquired by Intel. So these small companies, when a bigger company knows the technology is a complementary technology to they have, they normally go and acquire that. Right? And together they offer a much bigger user experience and solutions to them. And ASICs. So in the evolution of chip design, right, people started having microprocessors. Then when they found that microprocessors are not suitable for doing a specific type of functionality that they want to achieve, they started designing chips which will do a very specific function that they want to do. That is called as ASIC, application specific integrated circuit. Unlike a microprocessor, these will not have arithmetic logic unit, or this will not have a control unit, or this will not have any other memory management unit. All of these things will be there in a CPU. So ASICs long have been used for different functions. Any chip company other than the microprocessor companies like AMD and Intel, rest all companies can be called as an ASIC company. Now, if you have a specific ASIC working for an AI purpose, then it is called an AI company. So, it is basically fundamentally the same technology, the same chips that are doing the function. Depending upon what purpose it is deployed for, they have a unique differentiating name. That's it. As I said, neuromorphic chips, right? They are inspired by human brain and they help neural networks to simulate very closely. The biggest advantage of neuromorphic chips is they need very low power compared to your traditional chips and AI chips, and they provide low latency as well. That low latency means quicker transactional efficiency. Mostly, neuromorphic chips are deployed for the medical field in terms of identifying what are all the different molecule patterns that are needed for the drug research and all those things. So, neuromorphic chips have a major research interest in that. And quantum processors are in a very nascent stage, just like your CPUs, which are based on one human architecture and your digital logic. This quantum processors are based on qubits or quantum bits that they call us. So, how does an AI chip work? Different from a traditional chip, right? General purpose CPUs are designed for a broad range of tasks, whereas AI chips are specifically designed for a particular type of function, which is matrix multiplication. And then higher memory bandwidth. Memory architectures may not be optimized for AI patterns in a CPU. You have different memory configurations. Whereas for AI chips are equipped with high memory bandwidth, because it has to work on a large data set, right? You need larger idea about what is the cost of operating a particular AI function, right? Compared to the cost of it. I will walk through it and maybe give you the comparative study of what it takes to run an AI chip. You have produced it, that's okay. But if you have to run it continuously, what is the cost associated with it? And how different techniques in the engineering are followed to reduce the power, to give a better advantage. And if I have to talk about the use cases and applications, right? Data centers and cloud computing. Any website that you normally go and type in your Google or in your is basically going and picking a rack of CPUs which are arranged in the form of a card, and thousands of such cards are arranged in the form of racks. Those racks are called servers. So multiple of those servers constitute your data center. So for data centers and cloud computing, the AI chips, that CPUs were used earlier, GPUs and AI chips are used now. And edge computing and IoT devices. Edge AI or IoT AI is nothing but any